Good morning, children. We will start Polynomials Session 3 today. So, before I start with the session, few things I would like to make very clear. I also repeat that in my video every day when I teach. As well, I think I have already messaged you all and given the proper instructions how to write in your notebook. That is mathematics, whatever we do in the class, how to write in the notebook. I repeat that once again. You all have received this 400 pages, this long book, correct? That means in this book, you are supposed to write the mathematics chapters, whatever I teach in the class here. That means that consists of all the definitions what I write. I tell you all, correct? Definitions, please make a note and then start. That means definitions also you have to write. Exercise what I teach, you have to write. I give you homeworks to do. That also in the same book. And today we are starting with optional exercise of polynomials. That means it is an exercise of your chapter itself, correct? That also in the same book. You might be wondering why is it again and again I am repeating. That's only because again and again I am getting calls and messages. Where should we write homework? Where should we write optional? Should we write definitions? Should we write exercise? So I thought today I'll clarify these things, telling that everything what we do in the class, that you need to maintain the record in this book. Only tuition work what we do, right? Very clear? Okay. Next, you all have received this type of a book, which is a question bank assignment book, which I have given you long back in the beginning. Question bank for both science and mathematics. Now, mathematics question banks chapter wise, where should we write? So, for that, please maintain a separate book. You can either make a separate book all by yourself or write in sheets. Clear? This book is only for the tuition work chapters what we do. So, I think the things are very clear now. So, let's proceed with the chapter. Okay, so today we will start with polynomials optional exercise. In my previous video in the session I had told that we will start with the next chapter, linear equation. Then it just slipped from my mind that we also have an optional exercise. We will complete the optional exercise and then we will move on to the next chapter, that is pair of linear equation in two variables. So, before I start with this, now we are going to start with cubic polynomials. Now, in the exercise, what all we had done, that was about a quadratic polynomial, correct? So, what is a cubic polynomial? A polynomial of a form ax cube plus bx square plus cx plus d is a standard form of a cubic polynomial. Then, what are the zeros of a cubic polynomial? Alpha, beta, gamma are the zeros of the cubic polynomial. Alpha and beta are the zeros of quadratic polynomial, correct? Alpha, beta, gamma are the three zeros of the cubic polynomial. That means sum of the zeros, product into sum of the product of sum of the zeros and product of the zeros can be written as sum of the zeros alpha plus beta plus gamma is equal to minus coefficient of x square upon coefficient of x cube, that is minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x divided by coefficient of x cube. So it is c by a. Last, product of the zeros constant, that is this, minus constant upon coefficient of x cube, that is minus d by a. There is no derivation for this, so you need to just write it down as it is. Now, for a quadratic polynomial, standard form you knew how to write if the sum and the product of the zeros were given, correct? Similarly, the standard form of a cubic polynomial, if you know the sum, if you know the product into sum of and the product of zeros given, the polynomial can be written as x cube minus sum of the zeros of x square plus product of the zeros, like product of the zeros taken two at a time plus of x minus product of zeros. Same how we did for quadratic polynomial, that is zeros were given and we substituted. The same thing we have to do it for this also. Now I want you all to give the heading as cubic polynomial and write down this till here whatever I have given in your book. So first you complete this. After this we'll start with the exercise. So children, now we'll begin with the optional exercise of chapter polynomials. Yes, before I start with this, in the previous session, in the previous exercise, I had marked few homework sums. So you all know that you can check the answers behind what it is given, correct with that, put a tick bar. In case if you get a wrong answer, try to resolve it again. But still if you are not getting it, you can always call me to confirm. So one student had a doubt in one of the question here of the homework sum given. I will be solving that at the end of the session. We will first complete the optional exercise. First one, verify that the numbers given alongside of the cubic polynomials below are the zeros. Okay. Also verify the relationship between the zeros and coefficients in each case. Now verify the numbers are given alongside. Now beside the cubic polynomial, few numbers are given. Half, 1 and -2 are their zeros. We need to confirm that, verify that they are the zeros. Now how do you verify that the given numbers which are along the side, beside of the cubic polynomial are its zeros? Try to recall from your 9th standard, how do you check that it is a zero of the given polynomial? When we substitute each one, say first half, 1 and -2 in the polynomial, its answer has to be 0. That means remainder will come as 0. Correct? If remainder is 0, the given number is the 0 of the polynomial. This was done in 9th standard. Same principle we apply it here also. So in optional exercise, first one I will be doing it. First part I will be doing it. There are 2 sub questions. Second sub question I have marked for homework. This is the only homework sum in the optional exercise. So we'll quickly begin with the first one in that is 2x cubed. Now so what I will do here is I will write it off as let p of x is equal to 2x cubed plus x square minus 5x plus 2. And what are the numbers given? They are given as half, 1 and -2. I have to verify that they are the zeros. So confirm that they are the zeros only. So solution should be, remainder should be 0. Let's do for the first part. P of half, if I substitute, what will I get? Wherever x is there, go on substituting half. 2 into half whole cube plus half whole square minus 5 of half plus 2. See here, please do not cancel 2 and 2 because it is an exponent, cube is there. Simplify the cube and then only you can cancel. 2 into, this is 2 cube is 8 plus 2 square is 4 minus 5 by 2 plus 2. Now 2 ones are 2 fours are 1/4 plus 1/4 minus 5 by 2 plus 2. See, now we know 1/4 plus 1/4 is 1. If I write 1, again I have to take LCM. So directly we'll take LCM and we solve. Now we know LCM trick. 4 and 2 is there. So what's the LCM? 4. So here it is into 1, into 1, into 2, into 4. So this is 1 plus 1 minus 10. 4 twos are is plus 8. So 8, 9, 10. 10 minus 10 divided by 4 is equal to 0. So P of half is 0, right? So according to them, verify that they are zeros. We will write therefore, conclude after each what you write. Half is the zero of the polynomial. See, polynomial I have written as p of x, no? Write off p of x here. Simple. Otherwise, you need to again write polynomial. Therefore, half is the zero of the polynomial p of x. Now, did you remember what you had done in 9th standard? Now, similarly, let us apply this for 1 and minus 2 also. Please comment on this. So, the next part, I will do that as p of 1 is equal to 2 into 1 cube minus 1 square minus 5 into 1 plus 2. So 2 into 1 cube is 1. So 2 into 1 is 2 minus 1 minus 5 plus 2. 2 plus 2 is, I think we have gone wrong. 1 second, because we need to get 0. Okay, I went wrong here. This is plus. Yes. So this will be plus. So 2 plus 2 is 4. 1 minus 5 is minus 4. Therefore, p of 1 is 0. With 1 minus sign here and there, the whole sum will go wrong. So give the conclusion. Therefore, 1 is the zero of the cubic polynomial. Conclusion is must and should for these type of sums. Cubic polynomial p of x. Last one, which is minus 2, let us substitute. I will be doing it here. P of minus 2 is equal to 2 into minus 2 whole cube plus minus 2 whole square minus 5 into minus 2 plus 2. Negative number raised to odd power, answer is negative. 2 cube is 8. 8 2s are 16. Minus 16. Negative number raised to even power, answer is positive. 2 square, answer is 4. Minus into minus plus 5 2s are 10 plus 2. 10 plus 4, 14. 14 plus 2, 16. Minus 16 plus 16. So, p of minus 2 is equal to 0. So, everywhere we have got 0. Conclusion, therefore, minus 2 is the zero of the cubic polynomial p of x. That's your conclusion. This is how you are going to solve the sum. Quite simple. Similarly, as second one I have marked for homework. This first week only one. In this optional exercise, only one I am giving it for homework. So you all can do the same thing here. Now, since we have found out the zeros of the cubic polynomial, now we have to also verify the relation between zeros and the coefficients in each case. Now, what do you mean by that? These are the zeros of the polynomial. We have to verify the relation between the coefficients and 0. How do we do that? That's the verification part. After we finish this, then we'll start verification. Please copy down this. They have asked for verification. So, after we finish comparing all three zeros, that we found out that these are the zeros. Yes, these are the three zeros of the cubic polynomial. We confirmed it. Let's verify them. Verification. So, in verification, what we do? Try to recall. We again write the same thing. So, this polynomial, this p of x is equal to 2x cube plus x square minus 5x plus 2. Compare this polynomial with the standard polynomial, that is ax cube plus bx square plus cx plus d. That means what is your a is equal to here? A is equal to 2. What is your b is equal to 1. C is equal to -5 and d is equal to 2. Okay. What are your 3 zeros here? Do you know that? So let alpha is equal to 1 by 2, beta is equal to 1 and gamma is equal to -2. Why? I can also take alpha as -2, beta as 1 and gamma as 1 by 2. Anything. 3 zeros of the polynomial. So let alpha is equal to 1 by 2, beta is equal to 1 and gamma is equal to -2 because these are the 3 zeros of the given cubic polynomial. Now we have to verify. Verification first term is alpha plus beta plus gamma is equal to what? Minus b by a. Right? Formula which we have already written it. Substitute it in both the sides. Let's verify LHS and RHS together. What's alpha? 1 by 2. What's beta? 1. What's gamma? -2 is equal to minus in the formula b. B is 1, a is 2. So how do we do this now? Half, see, don't take LCM since the numbers are quite simple. Half 1 minus 2 is -1 is equal to -half. What is 1 minus half? It is half but greater number sign. -half is equal to -half. Verify the first one. Correct? I do not have a space down. I will be doing this beside this, but please you have to write it one below the other. So please follow the instructions what I clearly give while teaching. So I'll just draw a line and do this beside here. It will be easy for me. Okay. Next, alpha, beta, gamma is over. What is the next part? Alpha, beta plus beta, gamma plus gamma alpha is equal to C by A. Correct? Substitute the values. Your alpha is 1 by 2 into 1 plus beta is 1 into -2 plus gamma is -2 into 1 by 2 is equal to C by A. C is -5, A is 2. Half into 1 is half. -2. 2 and 2 will get cancelled. -1. So is equal to -5 by 2. So take LCM if you want here. Or what we can do here is half -3 is equal to -5 by 2. Now LCM is 2 into 1 into 2. So this is 1 minus 6 is equal to -5 by 2. 1 minus 6 is -5 by 2 is equal to -5 by 2. Verified. Right? Last one. Shall I do it here? See, I am doing it clearly. First this part, second this part, last is product. Product is simple. I will just do this here. Product of the root alpha, beta, gamma is equal to -b by a. Formula you need to remember very clearly with plus or minus sign it is. What is your alpha? 1 by 2. What is your beta? 1. What is your gamma? -2 is equal to b by a. Your d is 2. Formula is -2 by 2. 2 and 2 will get cancelled. -1 is equal to -1. Did we verify everywhere? Yes. So sum of the zeros we verified, this we verified, as well as product we verified. Do it neatly and clearly. Verification when you start, first comes this sum of the zeros. Taken 2 zeros at a time, product with the sum of the zeros. Third comes the product of the zeros. This is the way you have to solve the sum. Please copy it down neatly, one below the other. And copy the next question. Second one, find the cubic polynomial with the sum of the product of its zeros taken 2 at a time and product of its zeros as 2 minus 7 and 14. Understand the question very clearly. Try to understand what is given. They have given find a cubic polynomial with the sum. That means first one is sum of the zeros. Second one is sum of the product of two zeros taken at a time. What is that? Alpha beta, beta gamma, gamma alpha. Third one, product of the zeros. That means they have given us three zeros of the polynomial in the form of sum of the zeros, sum and product taken 2 at a time and product of the zeros. With that, we have to frame a quadratic polynomial. So we know how to do that. So solution. So what they have given? Alpha plus beta plus gamma. Sum of the zeros is given as 2. Then alpha beta plus beta gamma plus gamma alpha is given as minus 7. Now here we cannot change the order. We have to go as they have given respectively. Last, product of the zeros. Alpha beta gamma is equal to minus 14. So this is given to us. Now we know how to frame a cubic polynomial. This write down the standard form. Always do stepwise. The standard form of cubic polynomial is, what is it? X cube minus alpha plus beta plus gamma of x square plus alpha beta plus beta gamma plus gamma alpha of x minus alpha beta gamma. We have written this in the starting part. Substitute the values. X cube minus alpha plus beta plus gamma is 2x square. Now it is plus here, directly I will take because alpha beta gamma is minus here. So plus into minus is minus 7x. Question is minus. Alpha beta gamma is also minus. Minus into minus plus 14. This is the cubic polynomial. Now see here, this was minus. Minus into plus, answer will be minus. It is minus here. This is also minus. Minus 14 into minus, I got plus. This is the way how we have to frame an equation, that is a cubic polynomial. We know how to frame for a quadratic polynomial. We had that in the exercise. Copy down this quickly and next copy the next question. Third one, if the zeros of the polynomial x cube minus 3x square plus x plus 1 are a minus b, a plus b, find the value of a and b. So they have given us the zeros. That means let alpha is equal to a minus b, beta is equal to a, and gamma is equal to a plus b. That is what they have given. If you equate the equation to 0, what will be your values? A is equal to 1, not this a and this b here. Do not get confused with that. So a is equal to 1, b is equal to minus 3, c is equal to 1, and d is equal to 1. This one is different from what we have written. This is by equating the equation to ax cube plus bx square plus cx plus d. Yes. So let's find the value of a and b. Let's first start with the sum of the zeros. So alpha plus beta plus gamma is equal to minus b by a. What is alpha plus beta plus gamma? So it is alpha, that is a minus b, plus beta is a, plus gamma a plus b is equal to minus of minus 3 by 1. Yes, minus in the formula, minus for b also. Plus b minus b gets cancelled. So what will remain? 3a is equal to minus into minus plus 3. Therefore a is equal to 1. 3 divided by 3, 1. We found out the value for A. Now we have to find out the value for B. Now you have to know that, and that comes out only by practice. Should I apply the next rule, that is 2 zeros taken at a time, alpha, beta, beta, gamma and gamma alpha, or no? You should be knowing that depending upon the given question. Now here with the help of this I could find A very easily. I will skip the second thing because I have to find B. They have not told us find sum of the zeros, product, sum and the product taken at a time and product. To find B, what I will do is I will directly take product of the zeros. Alpha, beta, gamma is equal to minus B by A. What is your alpha here? Write whatever they have given. A minus B. What is your beta? A. What is your gamma? A plus B is equal to minus B by A, that is minus 1 by 1. I will be doing it here so that it is clearly visible. Okay. A plus B, A minus B, which identity? A plus B, A minus B, A square minus B square. A of, one A is remaining here, A square minus B square is equal to minus 1 by 1 is minus 1. Now do we know what is the value of A from the previous part? Substitute in this. So 1 square minus B square is equal to minus 1, which is nothing but 1 square is 1, 1 into 1 will be 1 only. 1 minus B square is equal to minus 1. Minus B square is equal to minus 1. Transpose 1 this side, minus 1. Minus B square is equal to minus 2. Minus and minus can get cancelled. B square is equal to 2. B is equal to plus or minus square root of 2. A square root always have two values, plus and minus. You have done that by plotting it on the number line. When we plot root to a number line, it comes as plus root 2 as well as minus root 2. Therefore, A is equal to 1 and B is equal to plus or minus root 2. This is the final answer of the given question. We are left with the last two sums. Quite lengthy sums we have here. I want you to write this down and then switch over to the last two sums. Fourth question. If two zeros of the polynomial, it is a biquadratic polynomial, are 2 plus or minus root 3, find the other zeros. This is the similar sum which we had done in the last previous exercise. Obtain all the zeros of the polynomial if zeros are root 5 by 3 and minus root 5 by 3, which we had done. Similar sum. So they have given us a biquadratic polynomial and they have given us two zeros. Now here it is given in the form of 2 plus or minus. That means let P of x be this polynomial. The zeros, okay, I write off this in the solution. This is solution only actually because let I have already written. Solution, let P of x is equal to x raised to 4 minus 6x cube minus 27x square plus 138x minus 35. The zeros of the given zeros of, why? Because we have to find two more zeros. The given zeros of P of x are 2 plus root 3 and 2 minus root 3, right? 2 plus or minus root 3 they have given. So these two are the zeros of the given polynomial. Remaining two we need to find. Now let's go, we'll go back again. If these are the zeros of the polynomial, that means we need to understand what could be the factors of this, and that is a factor of a given polynomial. This implies, Now see here, both are plus, only this part is minus. This implies x minus 2 plus root 3 and x minus 2 minus root 3 are the factors, are its factors. Okay? See, why x minus? Suppose if this was only root 3, I would have written as x minus root 3, whatever it is that side. Both are in the form of plus only. So, x minus 2 plus root 3 and x minus 2 minus root 3 are its factors. Let us first simplify. Now, here we have to simplify the factor in the simplified form before we proceed with the sum. That itself is quite heavy. Okay. Since minus is there, x minus 2 minus root 3. I'll use a bigger bracket. I'll tell you why later. And this one will be x minus 2 minus plus root 3. Okay. If I group this x minus 2 and x minus 2, it is of the form a minus b a plus b. Very clear? See here. A minus b, a plus b. Do it very slowly. You will understand. I have only removed the bracket, but after that I got x minus 2 same. One is minus, one is plus. That means it is a square minus b square, which is nothing but x minus 2 whole square minus 3 square. Simplify that now, which is nothing but x minus 2 whole square. A square minus 2ab, 2 2s are 4x plus 4 minus, it is root 3 square. So square and root will get cancelled. So it is 3. So what will remain? X square minus 4x plus 1 is the factor of the polynomial p of x. Understood till here? So this is the factor of the polynomial p of x. Now since we have understood the factor, we will divide the polynomial p of x by this factor so that we get the remainder 0 and we get a quotient. Further, we factorize the quotient to get the remaining factors. Correct? So since I don't think division will fit in this much, I need to erase what I have written and then freshly start with only division part. I want you all to first write it down since I will be erasing this now to do the division process. I explain once again, this is the same thing what we have done in the exercise, but here the given zeros are quite different. So we had to find its factor. Their finding factor was very simple since it was a monomial. Here it is a binomial. Same principle we have applied here and we arrived at the factor of this given polynomial. Let's divide this factor with the given polynomial to find its quotient. So now what we have to do is let us divide the factor with the given polynomial. So division process we know that. Try to eliminate the first term always. X square into x square will give me x raised to 4 minus 4x cube plus x square. Subtract it, change the sign. So x raised to 4 will get cancelled. Minus 6 plus 4 will give you minus 2x cube minus 26 minus 1 will give you minus 27x square. Write the remaining terms as it is. 138x minus 35. Since we have minus 2x cube, this is going to be minus 2x. Minus 2x into x square will give you minus 2x cube minus plus 4 2s are 8x square minus 2x. Change the sign, subtract it. Yeah, yesterday there were a few clarifications where I corrected. One of the students had actually asked me, when you change the sign, children, it has to be for everything, for all three terms what you multiply. Some of you will only change for one and leave it for remaining thing. Sign changes is done for all. Please refer the example how I do it first. Minus, and this will become plus. So whatever term I write, it's a trinomial, I change the sign for this, this as well as this, correct? So minus plus cancel, minus 27 minus 8 will give you minus 35x square. 138x plus 2x will give you 140x minus 35 as it is. 35, bring it down as it is. I got minus 35x square, already x square term is there, so I only multiply this by minus 35. So what should be the remainder? Remainder should be 0 because it is a factor. Minus 35 into x square, minus 35x square. Minus 35 into minus 4, 35 fours is 140 plus 140, 140x. Minus 35 into plus 1, minus 35. Everything is getting cancelled. Plus, minus, plus. So this cancellations only in pencil, and when you do write these signs here or numbers here, no overwriting on the sign. So answer is 0, that is equal to r of x. Right? What's the last and the final step? To find the factors of the given polynomial, since this divides this completely, leaving a quotient here. So, last step, factorize q of x, that is equal to x square minus 2x minus 35. We know the factorization rule. We always multiply first and last term. So when you multiply first and last term, you get 35x square. Factors of 35x square, 35 ones are, then 7 5s are 35. X and x. You want minus 35x square. 7 and 5, when you find the product, you get 35x square. But when you subtract that, minus 2 you want. So it is minus 7 plus 5. Minus 7 into plus 5, minus 35x square. Minus 7 plus 2, minus 2. Write it. X square by splitting this middle term. Minus 7x plus 5x minus 35. X common. X minus 7, again we write x minus 7 as it is here. Then check x into what should give you plus 5, it is plus 5. Plus 5 into minus 7, minus 35. X minus 7 and x plus 5 are the factors of the given polynomial, right? But what do we want? We want zeros. Therefore, we equate the equation to 0 to find this 0 of that. X minus 7 is equal to 0 and x plus 5 is equal to 0. X is equal to 7 and x is equal to minus 5. Give the conclusion. The 4 zeros of polynomial p of x are, first write the one which they have given. What is that? 2 plus root 3, 2 minus root 3, 7 and minus 5. These are the 4 zeros of the given polynomial. So the same way what we had done in the previous thing also. Please write this down and then we'll move on to the last one. Fifth one, if the polynomial x raised to 4 minus 6x cubed plus 16x squared minus 25x plus 10 is divided by x squared minus 2x plus k, the remainder remainder comes out to be x plus a. Find k and a. Now the remainder comes out to be x plus a, but there is no x term is there, but there is no a term. So how will the remainder come out as a? That means the remainder will not come out exactly as x plus a. The remainder comes out in the form of x plus a, where whatever remainder we get, we have to compare that with x plus a, where x is a variable and a is a constant. With that, you have to find the value of k and a. So let's do this with the same usual long division method. So let's start with this. Since we have to eliminate the first term, so x into this, x into x square will give you x raised to 4. X into minus 2x is minus 2x cube plus kx square. Change the sign. Minus x raised to 4, x raised to 4 will get cancelled. 6 minus 2 minus 4x cube. Now this k term and x term will remain as it is, plus 16x square minus kx square minus 25x plus 10. We actually have to take common since x square term is there. We'll take that later. Eliminate the first term, minus 4x. 4x into x square is minus 4x cube minus minus plus 8x square minus 4kx. Minus plus minus plus. Change the sign. 4x cube and 4x cube will get cancelled. 16 minus 8 is 8x square. Then what else will remain? We have a kx square, 4kx. Nothing can be simplified since they are unlike terms. Write them as it is, minus. After this, I will write the next x square term, kx square. Then I can write this minus 4kx, or we'll write first this term here, minus 25x plus 4kx plus 10. Let's check with the sign once again. 16 minus 8 is 8x square minus kx square minus 25x plus 4kx plus 10. Again, now see here, to cancel first term, we have 2x square term. That means I need to cancel x square term at once only. So let's take common. So this whole expression will be written once again as, I will write 8 minus k of x square. Okay? Remaining term as it is. We need to take common here also. But again we have to simplify further. So let's keep that as it is. After further simplification, we'll take common there. Minus 25x plus 4kx plus 10. We need to eliminate the first term. So I need x square is already there. I need to multiply this with plus 8 minus k. 8 minus k into x square. 8 minus k x square. Next, 8 minus k into minus 2x. Minus 2x of 8 minus k. 8 minus k into k is plus k of 8 minus k. As it is, I have multiplied. Change the sign. Minus, plus, minus. Cancel. Now here, let's first open the bracket to simplify that first. So if you have to simplify, how can you simplify this? What we will go now is, here, to simplify better, we will rewrite these two once again. Simplification will be easy. With the sign only. First I will write this part. How will I write this? Minus 25x plus 4kx plus 10. Okay. Now I will write this part. How to write this? This is plus. So forget this sign. I'll just cover this. 2x into 8 will give you 16 plus 16x, because plus sign is there. That's why I'm holding this. 2x into k will give you minus 2kx. Very clear? This we we'll keep this as it is because it doesn't make any difference. Minus k of 8 minus k. Right? Understood what we have done? I took this sign here, k of 8 minus k, remaining this. Don't change the sign again because we have already changed the sign and we wrote here. This upper term I wrote here for simplification. I just close this since this is plus 8 2s are 16 plus 2kx into x is minus 2kx. This minus sign k of 8 minus k. So let's solve this now. No more changing sign as I have told you because already we have written after changing the sign. Minus 25 plus 16. 25 minus 16 is 9. Greater the number sign will come. So this is minus x. 4 minus 2 is plus 2kx. Remaining term, let's write it as it is. Minus k of 8 minus k plus 10. Now let's take common. This is the last step, nothing more doing further. So here x is common. So if x is common, minus 9 plus 2k of x minus k of 8 minus k plus 10, and this is the remainder of the given polynomial. Is this of x plus a? Yes. This is of the form x plus a. How? Just see here. This is of the form x. This is of the form a. Where when we check the coefficient of x is minus 9 plus 2k. Coefficient of x is 1. Coefficient of a is minus k of 8 minus k plus 10. That is what the question they had given. You get the remainder as x plus a in the form. This is the form what we have got, and now we have to find the value of k and a. So I do not have space here. I will be just doing it in this part. So please do it one below the other. Now I have already written this is in the form of x plus a. Therefore the coefficients when we match, I will write here x is equal to, what is the coefficient of x? Coefficient of x is 1. Therefore, minus 9 plus 2k is equal to 1. Coefficient of x is 1 here. Okay, I'll write here comparing the coefficient of x and a. First, I have compared the coefficient of x. 2k is equal to 1 plus 10. 2k is equal to, 1 plus 9. Transpose this minus 9 to this side, you get plus 9 is equal to 10. Therefore, k is equal to 5. Did we find the value of 5? Value of k? Yes. Last. Let's find the value of a now. So what is the coefficient of a here? So minus k of 8 minus k plus 10 is equal to a. What is k value? 5. Substitute. Minus 5, 8 minus 5 plus 10 is equal to 8. Minus 5, 8 minus 5 is 3 plus 10 equal to 8. 3 5s are minus 15 plus 10 equal to 8. Therefore, a is equal to minus 5. It is not necessary of to get both sum as plus or minus. We got it here. So, value of k is 5, value of a is minus 5. That is how we solve this. Quite a lengthy one. But you need to be very careful with the sign. One sign, if you go wrong anywhere, answer is wrong. Practice this, you will get the answer. So there we complete the optional exercise. Now as I had told, there is one sum where the student had asked me that a homework sum was not able, she was not able to do the homework sum. So let's do that one sum and conclude with this chapter. So homework of session 2, that is previous session, first main, third one, divide the polynomial p of x by g of x, find the quotient and remainder. So this was the polynomial to be divided by this. Yes, and one and foremost thing what you have to do is whenever you write the polynomial, check the polynomial it is in standard form or not. Some of the students have just recently, I have just checked some answers of some students who have solved and said where there, though the answer was correct, but this was not arranged in a standard form. So please arrange this in standard form, that is minus x square plus 2 always. This has to be done in this manner only. So let's divide minus x square plus 2. So when you divide this with x raised to 4 minus 5x plus 6. Now in this polynomial, x raised to 4 is there, x raised to 3 is not there, 2 is not there, directly x is there and 6 is there. Some of you all will get confused while doing it. You can also write it as plus 0x cube plus 0x square minus 5x plus 6, assuming this and go on solving it. But I will usually not use it as 0 and 0, not required. We can also do it, but be very careful in subtracting. Where x cube and x squared terms are not there, do not subtract that with something else. We will directly do it as it is, minus 5x plus 6. Now look at this. This is the first one where we have a divisor first sign only as negative. We have to get answer in terms of x raised to 4, not minus x raised to 4. That means if I have to get answer as x raised to 4, with what I have to multiply? Minus into minus x square. Minus minus plus. Because the first term should be as it is always. Minus x square into x square is x raised to 4. Minus x square into 2 is minus 2x square. Subtract it. Change the sign. Now, you don't have anything of x square term there. So what to do now? We can't do anything. First, equation wise, x square term should come with respect to sign. 2x square. After 2x square, minus 5x plus 6, as it is, bring them down. You want plus 2x square. That means I have minus here. I have to multiply this by minus 2. Minus 2 into minus x square is plus 2x square. Minus 2 into plus 2 is minus 4. Subtract it. X square will get cancelled. 5x, we do not have anything to do with it. 5x as it is. Plus 6 minus 4. So sorry, plus 6 plus 4. Answer is plus 10. This is your remainder. That's all. Very clear on the sum how to do it. So copy this down. If you have already done it, just check with your answer. Remaining answers, as you know, you can always check with the answers given in the back. In case you get a wrong answer, try once again by re-watching the video, seeing the concept clearly. Even then if you don't understand, please call and confirm. So in today's class, if you have any doubt, please call on the same day of the video set. Tomorrow we will start with pair of linear equations in two variables.